Hey everybody, this is Larry. This is week 2 of the weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Apparently I've done it before, but let's take a look anyway. We have 323, number of connected components in an undirected graph. Okay. You have endnotes, edges, and then connect components. I mean, this is a pretty standard standard problem, textbook problem even, honestly. Like you'll see in a textbook, and there are 3 textbook ways of doing it. One is depth first search, one is breadth first search, and one is union find, or disjoint set union. I'm going to cheat a little bit to see how I did it last time. I erased it, as you saw, just so that I could do it another way is what I mean to do, because show you a little bit of practice, or maybe if you watch that video, then you get a little bit of a different one. So I did do it with PFS. So okay, so let's do it with depth first search then. Why not, right? Yeah. First we'll set up this adjacency list. I guess this part is not going to be that different for in general. Is this 0 index or not? I'm sorry if I'm not going into this in that much detail. I don't know if I need to. It is a very standard thing. I don't know. I mean, my apologies if you want more explanations, but definitely ask me questions. If you do, then I'll know how to kind of anticipate these things. But this is also, honestly, it's basic, not necessarily because it's easy, but because everyone is expected to know this. Like a lot of Leetcode and competitive programming and stuff, like problems built on similar components, if not exactly as a smaller basis, right? So you definitely need to know this. There's no way around it. You have to understand it. And also, as a result, there are a lot of good videos on this probably on the internet. So I don't know. I don't have much of the description, right? I'll tell you as I kind of do this, right? How I remember it is just, for each node that you haven't seen yet, then you visit all the, like a flood fill, right? You go to all. It's almost like you can think about it as a virus on a depth first search. You jump from everybody until you've seen everybody, kind of thing, and then everyone is happy, or I don't know, infected anyway. So yeah, so here we have right, we have node, we have, and that's it really, necessary. And we have maybe a scene. Is you go to set, you can actually you have to visit everything anyway, so we can just do for, so you go to end, right? And then yeah, if scene of node, then we return, otherwise we set it to true. And then we just visit all his friends. And adjacency list of nodes. If not scene of node, DFS node. Oh, oops, messed up already. But yeah, and then now the only thing you have to do is just do a for loop for the edge or the nodes, and you go if not scene of I, then DFSI. But also keep a count, because now that is one new component. And that's really it, right? Not much to it. Yeah. I don't really even know how anything else, but we look at each node once, we look at each edge once from each node, right? Maybe twice you will say it looks backwards, but of course it'll be seen, so it doesn't do that much. But yeah, that is all I have for this one. Let me know what you think. It's a little bit fast. It's a very basic thing. So let me know what you think. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.